In this video, let us see about the Dijitra's algorithm. So this is the single source shortest path algorithm which can be applied to a weighted graph. So this Dijitra's algorithm is mainly designed to find the shortest path between the two vertices of the graph. So these two vertices would be either adjacent to each other or it can be at the farthest point in the graph. So say for example, here we are going to consider a graph in which A is going to be the source node, and we'll find out the shortest path to reach the node B, node C, node D and node E. Assume that A is a city and we have to travel to different cities, say B, C, D and E, and we'll find out what is the shortest path to travel to different cities starting from the source vertex say A. Fine. So what will be the output of this Dijkstra's algorithm is the shortest path spanning tree. And let us now start solving the Dijkstra's algorithm. So say that A is a starting node and we have to maintain the table. So the table will contain 3 columns. So the 3 columns are, first is the vertex and next is the cost and third is the previous vertex. Fine. So let us now write down the different vertex of the graph. So the different vertex of the graph are A, B, C, D and E. Fine. So these are the different vertex of the graph. Now initially when we have to start from vertex A, okay. So when we have to start from vertex A, the cost to start or travel from vertex, the initial cost is going to be 0. And in order to reach the other vertex or the other cities, we do not know initially what is going to be the cost or the distance that is taken. So we'll define the cost to reach from A to B, A to C, A to D and A to E. We'll define it as infinity. So this is our first step. Now let us look into the table and let us find out first that we have to start from node A. So from node A, what are its neighboring nodes? The neighboring nodes are B and D. So let us fill up in the table. So let us again draw the table with 3 columns. Let us draw this. It's node A, B, C, D and E. Fine. Now this is vertex, cost and previous vertex. Now, just look at node A. So node A, what are its neighboring nodes? Is node B and node D, right? So for node A, initial cost is 0. And in order to reach from node A to node B, what is the cost that is taken? It is 6. And the previous vertex is what? A. And now we have to travel to node D from A. What is the cost required? That cost is 1. And what is the previous vertex? The previous vertex is E. So this is our second step. For the rest of all the nodes C and E, we'll mark it as infinity. Fine. Now let us draw so this is our second table. Now say that, see, when we calculated for node A, how do we calculate is, for starting from node A, the node A has got many neighboring nodes is node D and node B, right? So for node A, it is 0. So when we calculated for node B, it is 0 plus 6 and it is equal to 6. And here the edge cost is 1 and 0 plus 1, it is equal to 1. So that is the reason we have updated 6 and 1. Fine, now we have to apply the same thing to find the shortest distance. So in the next step, what we have to do is find out in this table 2 which node's cost is less. So we find that the cost of this node D is less with the edge cost as 1. Now so we have visited only one node, that is only A alone is visited, completed. And now we'll start to traverse from node D. So let us draw the node D figure. So for node D, what are its neighboring nodes? So you can see here node D has neighboring nodes as A, B and E. So let us draw this. So for node D, it is A, now B and E. So let us write on the edge cost. So 1, here it is 2 and for node A to D it is 1. Fine. So 1, 2 and 1 is written. Now let us calculate first the distance and let us draw parallelly the table for this. So we'll draw the table. So I'm just going to write down as just A, B, C, D and E. Fine. Now what is the distance for this cost for node D from the table already? It is 1. So from node D, when we have to travel through node D to E, what is the cost? It is 1 plus 1, so it's equal to 2. And now for D to B, so it is 1 plus 2, so it's 3. And 1 plus 1, so to travel, it is 2. Fine. Now let us look into the table. Now for node D, what is the cost already? The cost is 1, right? So let us write down the cost as it is. So the previous vertex is E. Now in order to travel to node B, okay, for node B, what is the cost here? Cost is 3, right? But what is the cost in the previous table? It is 6. So 6 is higher cost. So we will replace cost for node B as 3. And what is the previous vertex now? The previous vertex is D. Fine. So we have updated this entry. And now let us see what is the other vertex. So it is vertex E. Now for vertex B, what is the cost to reach through D? So through D it is 2. So let us update the previous vertex as D. Fine. So now let us fill up the rest of the entry. It is infinity, and for A starting vertex it is 0. Fine. So this is how we find out the shortest distance. Now look at the table again. So what all is being completed now for us? So we have completed here now the A. Fine. And then we have taken D as the source node. So A and D are done. Now among this node B, C and E, which vertex is having a lower cost? It is the node E, right? So now let us start with node E. So for node E, we'll draw the graph first. So for node E, this is node E. And what are its neighboring vertices? So neighboring vertices are D, B and C. So let us just take out this and draw it again. So for node E, it is B, C and E, right? So D, C and B. Now the cost to reach from E to C is 5, D to E is 1 and E to B is 2. So let us just write down it. 1, 5 and 2. The previous table we find that what is the cost for this node E? Node E is 2, right? So now let us write down node E cost is 2. Now from city E to C, so it is 2 plus 5, 7. Now 2 plus 2, 4. From E to D, 2 plus 1 is going to be 3, right? Now we will update in the table. Fine. So let us check out with the previous table what we have. So A, B, C, D and E. Fine. Now just look at the table. So from E to C. So first to reach C, what is the cost here? Cost in the previous table is infinity, right? So now we will update the cost to C. So C, it is 7 and it is the, what is the previous node? Previous node is going to be E. Fine. For A, we'll fill up 0. Fine. Now for node B, just check out for node B. From through E to node B, what's the cost? It is 4. But already the table has been filled with a lesser cost. So let us not replace it. Let us write on the same thing. Now for D, we are not going to change anything. It is fixed. Now for node E. Now for node E, is there any other path? No other paths. For node D, just check out. Here the cost is 3. So we are not going to update the cost of this vertex D. And let us write down, fill up the rest. So this is the updated table now. Now let us see for what all nodes we have completed. We have completed for the vertex A, now for vertex B, and then we have completed for vertex E. Now what are the nodes which are left out is B and C. So let us take out the node which has got a lesser cost. The node which has got a lesser cost is node B with the edge cost as 3, right? So let us draw the node B now. So say for node B, what are its neighboring nodes? Are node A, then node E, then node D and node C. Fine. So let me write down the edge cost. So 6, 2, 1, 2. Fine. Now for node B, what is the cost in the table? It is 3. So let us now find out, to reach from B to C, the cost is going to be 5 plus 3, it is 8. Fine. Now from B to E, 3 plus 2, it is 5. B to D, 3 plus 2, it is going to be 5. Now B to A, 6 plus 3 is going to be 9, right? So now let us see that whether we have to update it in the table. So for C, the cost is 8 through B, but it is already 7 here, so we don't have to update in the table. So let us draw this. So A, B, C, D, E. Now for C, we don't have to update as 7 is lesser than 8. So let us write down the same thing. Now for E it is 5, but E through D it is lesser. So let us write down the same thing. For A, let us mark 0. Now for D is already 1, but here it is 5. So let us not update it. So 1 and A. Now for A, it is already A is a source node. So for A is 0. Now for B, it is again 3 and D. Fine. So there is no updation that is being made right now. So we have completed now for the node A, for node B, for node D and node E. Now which node is left out is node C, right? So now let us see for node C. So for node C, what are its neighboring nodes? For node C, the neighboring nodes are B and E. So here for B it is 5, for E to C it is again 5. What is the cost for this vertex C? C is 7. So in order to reach the node B through C, it is 7 plus 5, so it's going to be 12. Here 7 plus 5, 12. Now when we look at node B in the table, fine, so it is only 3, so it is having a lesser cost, so we don't have to update in the table. Fine. So let us now write down in the table A, B, C, D and E. Fine. So B and E. B and E, the cost is already lesser. So 3 and 2. So let us not change it. So let us write down 2D. And therefore C, it is 7E. Now this is 1 and the previous, for D it is 1 and previous vertex is A. And for A it is 0. So this is the final table to find the shortest distance of the node A to various other vertex, say B, C, D and E. Fine. So we have visited A now, then we have visited D, then we have visited E, then B and finally C. Now let us see how to check out whether the shortest distance what we have got is right or wrong, right? So how do we do that is, so we have got the graph here, right? So let me draw the given graph for you again. So let us draw this. So it is vertex A to B, now B to C, now A to D, D to E and E to C. This is our given graph. So 6, 2, 1, 1, 2, 5 and 5. Fine. Now let me tell you, in order to travel from vertex A to B, okay, it has to travel only through what? D. The previous vertex for node B is D. So in order to travel from vertex A to B, it has to travel only through D and this is the path. So when you calculate it as 1 plus 2, it's going to be 3. Fine. So this is how we find the path. Now when you have to find out what is the shortest distance to reach the city C. So city C, if you have to travel, you have to travel through the previous node E. Fine. So previous node of C is E. Now look at for E. For E, what is the previous node? D is the previous node, right? Now the path will be from A to D, D to C, D to E, and then from E to C. So when you add, it is 5 plus 1 plus 1 is going to be 7. So you have got the cost here. Now to A to D, if you have to travel directly through A. So the cost is 1. Fine. So the cost here is 1. Now from A to E, if you have to travel through D. So how do you travel A to E? You have to travel through D. So it is 1 plus 1. The value is 2. So this is how you can verify that the shortest distance to travel from the node A to various other vertex of the graph is correct or not. Okay, fine. So next, let us see what is the time complexity of this Dijkstra's algorithm. The time complexity is going to be order of the vertex V plus the E log V. So E is the a number of edges in the graph. Okay, so the order of V plus E log V is the time complexity for the Dijkstra's algorithm. So the final graph what we have for the Dijkstra's algorithm is A to D, now D to B, D to E, and E to C. So this is the shortest path spanning tree which we have obtained for this given graph. Thank you.